Good morning, everybody. Um, if you want to follow along with the attached slideshow, that would probably be best because you're going to get problems in there, and we are going to be doing a bunch of problems today. It should not actually be pretty hard. This should be pretty easy because we kind of been doing this all year anyways. We just have to, continue doing it. So before we start, we are going to wait a few minutes to see if anyone else is going to hop on. But just as a reminder, those are some things that you need to remind yourself of that we've already done in class, and you probably have notes on somewhere that you should be referencing if you don't know what I'm talking about today. But I will go over each of those real quickly at the beginning as well. So. There is a docs. Yeah, it's attached. The problems are in the docs. There's only 12 of them, but I also think you probably know everything in this lesson already. So you can go ahead and do the docs, and that's what you're turning into me. There is also a discussion attached to this one. So you'll see a question that unlocked. I would like you to answer that discussion question by the end of the week and respond to 2 other people. Thanks, Anthony. Hopefully it gave you a grade right after. I will double check it and put it in. Where is the slides? The slides should be attached to the Google Classroom. You're looking at two-step equations. That's what we're looking at today, which really isn't too difficult to do. If you can do one-step equations, you can probably do two-step equations. You have a discussion question as well. If you look in the classroom, there should be a discussion question. I would like you to respond to that discussion question, and I would like you to respond to 2 other people's discussion question too. And if you could get discussion questions done by the end of the week, that gives other people time to respond and maybe even respond to yours, and they might have some insight on you. But you should be looking. You should be looking at this question here, which is in the Google Classroom, that you can respond to, and then you should be able to respond to other people's as well. I would wait to respond to it after the lesson because I will tell you the right answer to these things vicariously through the lesson here. I won't specifically do that problem, but I'll do problems that are very similar to it. All right, so we're going to jump in and we're just going to do a quick review of each of the 4 things that I wrote up here as a reminder. You are going to be needing to know this information in order to solve two-step equations. So first you need to understand your inverse properties. So your inverse properties are, okay, if I have the number 3, what do I add to 3 so I get 0? And what is that number? Well, that's your -3. So the inverse of adding by 3 is subtracting by 3. And then what do I multiply to 3 to get 1? What is this number? Well, that's 1/3, or I divide by 3 to get it. So those are your inverses. Just remember it's like the opposite operation, so to speak. But you do that all the time when you're doing one-step equations. Just start using the word inverse. Integer stuff. I gave you, a while ago, I gave you a flowchart to follow, But know your integer operations. Make sure when you're adding and subtracting, you keep your signs right. Right, so we have like -4 minus 5. Make sure you know how to solve problems like that. -4 minus 5. Signs are the same here, so you add them and keep the signs. So 4 plus 5 gives you 9, so that's -9. Sometimes you have different signs. If they're different, you subtract and keep the sign of the larger number, so this gives you a +1. Keep in mind if that was switched and you had 4 plus -5, you would be getting a -1. So remember those things. Then when it comes to multiplying and dividing, note that same signs equals positive and different signs equals negative. So that's integer operations. One-step equations, you've been doing those all year. Things like yeah, you can send a picture, Anthony. Anything you're missing that I still need, send a picture through my email. One-step equations are those things like 3 plus x equals 12. What is x? So you subtract 3 from this side, subtract 3 from that side, and you get these to cancel. You're left with x equals 12 minus 3 gives you 9. I'm sorry. Yeah, 9. And then you can check it by doing 3 plus 9 equals 12. So those things are one-step equations. Yeah, take a picture of the assignment and send it. Whatever you need to send to me. If it's handwritten, take pictures and email it now. Parts of an equation, those are things like what's a coefficient, what's a constant, what's a variable, things like that. So with that, we can get into two-step equations. They are going to look, and I have, following along with the PowerPoint, there's a whole bunch of examples we're doing today, and that's really all we're doing. They are not difficult because you've been doing them all year, but these are going to be like 3n minus 6 equals 15, and you want to know what n equals. You can solve this as long as there is only one unknown. If you have multiple unknowns, it's not solvable. Here we only have an unknown of an n, so we can solve this. We can figure out what n is. And what you want to do is keep in mind you are doing order of operations in reverse here. So we're going backwards to undo all of this. We're kind of working backwards. And again, you can put a line down here if you want. Just remember, hey, whatever I do this side, I need to do this side. And your goal here is to get n by itself. You want it to say n equals something. So you look over here and you decide, well, what's attached to n? What's happening here? You have 3 being multiplied to n, and then you have subtracting 6 from it. Well, order of operations in reverse says I want to get rid of that subtraction first. So what I'm going to do is, in order to get rid of -6, I do the inverse, which is add 6. So I'm going to add 6 to this side, and I'm going to add 6 to that side, making sure you do order of operations in reverse. I need to get rid of that addition and subtraction before I can deal with this multiplication. So in doing so on this side, I always choose things so they cancel. So this is going to cancel and leave me with 3n. Over here, 15 plus 6 gives me, what is that? 6 plus 5 gives me 11, gives me 21. So now I have 3 times n equals 21. So you can see how this was like kind of a one-step equation if you took this as just a variable, and then here's another one-step equation. So you just keep tacking on the same thing. You can continue your line down. In this case, we have 3 times n, so we want to multiply by the inverse, which is going to be dividing by 3. So I'm going to divide this by 3, and I'm going to divide this by 3. Over here, my 3's are going to cancel. I'm left with n. 21 divided by 3 gives me 7, so n equals 7. And I can go ahead and plug that back into my original equation. I have 3 times a 7 minus a 6, and hopefully that equals 15. And I can check that out. 3 times 7 gives me 21. 21 minus 6 gives me 15. So it works. So n equals 7 is my answer. And again, we've been doing things like this all year. We're just adding multiple steps to it. And eventually we'll get into more complicated ones, but leave that for later this week and next week. Any questions so far? All right, I'm going to go through the examples from the slideshow here, and then when I get to the end we'll do a word problem together, and you'll be on your own for the discussion and whatnot from that. I am just going to be doing, if you notice, the example problems are pretty much all the same, except I am changing signs on things just to get you used to that integer operations there, and remind you of those because they are a bit tricky at times. So here, yeah, Christian, this is what we're going to be doing for the docs. But yeah, it's probably been a while since we looked at some of this stuff. But we got 3n plus 6 equals 15. Here we have a plus 6 instead of a minus 6. So when we go to operations and stuff, again, order of operations in reverse, I want to get rid of addition and subtraction over here first. This says 3 times n plus 6. I'm adding that 6. I want to subtract it. I want to get rid of it. So I'm going to subtract 6 from this side and subtract 6 from this side. This is going to cancel out this and leave me with 3n. Did not touch the n, did not touch the 3. I just got rid of the plus 6. Over here, 15 minus 6 is going to give me that 9. Right? And then you're going to get n by itself by doing this one-step equation here. You're going to, again, you can continue that line down, divide this by 3, divide this by 3, you're going to get n equals, because this cancels, 9 divided by 3 gives you 3, so your answer is n equals 3. And again, you can plug that in and double check it. So 3 times 3 plus 6 should give me 15, and you know 3 times 3 is 9, 9 plus 6 equals that 15. So that one works out. Just different signs, different operations do different things. The next one is a little trickier, but it is really the same process. Just got to remember your integer operations here. So for this one we have negative 3n plus 6 equals 15. If you know how to do it, go right ahead, Peter. You can do it. I'm not going to hold you back from it. Again, I'm covering my ground. If you have questions on specific ones, you can always email me, and I'll respond as soon as I can. But I mean, it really is not difficult. I would pay attention to when you have negatives out here, just so you are aware that sometimes these negatives play effect and they do some weird things for you. But yeah, other than that, as long as you keep up systematically, it's pretty easy. Here we're going to, again, get rid of the addition and subtraction first. So I'm going to subtract 6 from here, subtract 6 from here, and this gives me negative 3n equals my 9. And then I have to divide this side by negative 3 this time as opposed to the positive 3 because it is a negative here. Divide this by negative 3. And in doing so, these are going to cancel, leave you with n. However, 9 divided by negative 3 does not equal 3, it equals negative 3. So in this case, n equals negative 3 instead. And you can figure that out by plugging it in. We have negative 3 times negative 3 plus 6. Negative 3 times negative 3 gives you 9. 9 plus 6 gives you the 15. So, easy enough there. Next one is when both of our numbers are negative here. So here we have a negative 3n minus 6 equals 15. So in this case, I mean, it is the same process. That's a horrible line. That one's not much better. Same process, order of operations in reverse, get your variable by itself. That's your goal. So which side has the variable? This side has the variable, get it by itself. It has a negative 3 times an n minus a 6. We have some addition and subtraction going on here, so let's get rid of that negative 6. So I'm going to add 6, do the inverse of it. Add 6 to this side. This gives me 21 over here, and this gives me negative 3n over here. Again, this is going to cancel. Now I still don't have n by itself, so I'm going to divide each side by negative 3. Divide this side by negative 3. These are going to cancel. It gives you n, and 21 divided by negative 3 gives you that negative 7. So in this case, n equals negative 7. I'll do 8 when I'm done here with this one, because I want to look at negative coefficients. I'm not sure which one number 8 is on there. But I'm going to look at the negative coefficient one first. This is kind of a strange case, but you just got to remember that that negative x is actually negative 1x. So this is 5 minus x equals 17. This is the same thing as 5 minus 1x equals 17. So keep that in mind. This is a multi-step problem, and you want to get rid of addition and subtraction first. So just watch your signs on things and watch your inverses. So I'm going to actually get rid of this because we don't normally use it. And we're going to look at solving this. So looking at this, it is a little tricky to see, but you are actually adding this 5. There's a plus sign in front of that 5. So we are adding that 5, so I'm going to get rid of that 5 first by subtracting it. So I'm going to subtract off the 5. Keeping in mind my 5's cancel, not this negative sign and not this x. So I'm left with negative x equals, and then 17 minus 5 gives you the 12. So negative x equals 12. Keeping in mind this is actually a negative 1 in front of here. You just don't write it. So I'm going to divide this by negative 1, and I'm going to divide this by negative 1 as well. That's going to cancel out my negative sign, leaves you with x, and over here you're going to be 12 divided by negative 1, which makes it negative 12. Or you could just use some reasoning. If negative x equals 12, then you know positive x is going to equal the opposite of that, which is negative 12. Let's look at number 8 now for James. And you guys can follow along with number 8. I just got to look at what it is. Number 8 says negative 7 plus 5x equals 23. So in this case, you can see that we are adding this negative 7, but really it's subtraction of 7 because it's a negative 7. In this case, again, draw your line. Inverse operation, I have a negative 7 here, so I'm going to add 7 to both sides. This is going to cancel. It's going to leave you with a positive 5x over here, but we don't need the positive sign. And over here we got 23 plus 7 gives you that 30. After that, you're going to divide by 5 and divide by 5. This gives you x equals 6. So there's your answer. And again, you can check it. We have negative 7 plus 5 times 6. 5 times 6 gives you 30, so negative 7 plus 30 gives you your negative, or I'm sorry, gives you positive 23, because the 30 is the larger. Can we do some of these in our head rather than writing down all of our work? That's up to you, John. I'm not going to see the work either way, but they do get a bit complicated at times, so just keep it in mind on just keep things straight, keep things organized. when we get into multi-step equations, there's going to be multiple steps to do, and I highly suggest you start writing things down. But yeah, you're right. Some of these you probably can do in your head. Like number 7 is negative 2x equals 4. Yeah, what times negative 2 equals 4? You know x equals 2 there. Or I'm sorry, negative 2 because it's a positive 4. But yeah, you can do some of those in your head. Yeah, Grace, you can start on the Google Docs. I'll be here if you have questions. I am going to... I'm going to leave that up. There's a word problem just for, hey, how do I actually use this in real world here? I'd like to go over with you as well once I get it up here. So here's an example of the kind of problems you're going to see in real life where you can set it up as a word problem and go from there. So here it says Lynn wants to save. That should be save. Well, I try to erase it. Save $900 to go to Puerto Rico. She saves $40 each week and now has 180 solved. I'll do number 5 when I'm done here. To find how many more weeks she needs to save, use this equation here. So this equation makes sense. We have a constant amount of 180 already saved, and then we're saving more, and we're saving how much more? Well, it's 45 per week, so that's $45 times however many weeks we have, and we need to add up to 100 or to 900, so you can easily get your equation out of that. But again, you're just solving for W, so here we're going to take care of addition and subtraction first. So we have this 180, let's subtract it. Again, it is a positive 180 because that sign out front is positive, so we are going to subtract it. So subtract the 180 from it, minus 180, and that makes sense in our head if you were to solve this without the equation. You're like, hey, I need $900, I have 180 saved already. How much more do I need if I'm saving 45 a week? Well, let's figure out how much more you actually need first and get rid of that 180. So 900 minus the 180 gives you 900 minus 100 gives you 700. That's 620. Okay. I don't know. I'm not doing math in my head right now. It's 720. That gives you the 720 equals 45W. And again, this is going to cancel. And then you just divide each side by 45, divide that by 45, 720 divided by 45, I want to say it was like 8, but I'm not sure. 16. W equals 16. So it's going to take her 16 more weeks. So just for a context of the problem, 16 more weeks. You sure, Jack? I can do it. You got time to do number 5. Any questions on any of the other ones? I will stay on as long as we have questions. Other than that, we're pretty much done for today. Just make sure you answer the discussion question and make sure you finish the Google Docs. If you understand, then you're good. Again, it really is mostly a review today, so. Just a reminder to make sure you get your science stuff in, and make sure if you did not submit a quiz to me, make sure you do that. I didn't get a chance to look at everybody's yet. Still working on some of this. When you're done, make sure you answered the discussion question and make sure you turn in the Google Docs. And that's it for math. I'm not going to go into the next step, even though it's not too difficult, but you got to get this down first. And hopefully most of you already have this down. We've been doing stuff like this all year just for this reason, so this chapter becomes easier and easier. Yeah, watch your integer work, guys. I'm seeing some mistakes already. I do not think any of these should be giving you decimal answers. I'm not doing decimal answers yet. Number 10, sure. Yeah, Sal, we should not be getting decimals here. Like number 4 is right up there. This cancels, gives you x equals a negative 12 divided by 3 gives you negative 4. If you're getting decimal answers to things, you probably are messing up your integer work. So use the flowchart that I gave you at the beginning of the year, or use a calculator. Number 10, let's do number 10. We got a negative 5 minus 7x equals a negative 68. This is we're probably not getting it because of signs, so pay attention to signs. I'll do 9 and 10. This is number 10 first off, so let's start with 10. Here we have order of operations in reverse, get x by itself here. So I'm looking at this side of the equation. I got a negative 5 here, so I want to add 5 to both sides. Watch what cancels. This negative and that positive 5 cancel. it leaves you with a negative 7x. So watch that, and be careful with your integer work over here. Signs are different here, so we have a negative sign and a positive sign. You should be subtracting these numbers to get your number. It says 68 minus 5 gives you a 63, and it is a negative here, so this is a negative 63. In that case, that is probably where you made your mistake, but here we have a negative 7x, so we're going to divide by negative 7. Those will cancel, make a 1, leave you with x. Over here you have to divide by negative 7. Be careful, these are both negative, so your answer will be positive, and 63 divided by 7 gives you 9. And we can double check that by plugging it in. We have negative 5 times negative 7 times 9 equals negative 68. And here you're going to get negative 5 minus 63 equals negative 68. And then it checks out. They are the same, so negative 5 minus that gives you negative 68 equals negative 68. So that works out well. Let's look at number 9. Number 9 says 6x plus 5 equals negative 67. Again, the mistake you're probably making is the integer operations. So use your flowchart I gave you. Remember those rules. Here, we want to get x by itself. You're adding anything? Yeah, you're adding a 5 here, so let's subtract the 5 from both sides. This gives you 6x. A plus 5 and minus 5 cancel. Here, where both sides are negative, so you're actually going to add your numbers and get a negative answer. So it's going to be a negative, and then 67 plus 5 gives you an 82. So that's a negative 82. And then you're going to divide each side by 6. And hopefully 82 is divisible by 6, which it's not, is it? Did I do that wrong? I'm sorry, that's a 72. That's where I went wrong. This is a 72. 72 divided by 6 gives you that negative 12. And you can check that. 6 times negative 12 gives you that 72, or the negative 72. And then you want to add 5 to that to get your negative 67, which will work. Are there any other questions on them? Does anyone want me to do an example or another one on there? 10 is negative 5 minus 7x. Not sure what you mean by that, James. I think you held shift during your equal sign. Number 10 should be, we just did 10. I can do 10 again if you want. 10 I'm getting as negative 5. Never mind, you sure? Alright, well, if you're good, you're good. that gives you a positive. I guess if you have any further questions, feel free to email me. I will make a little video for you if you don't know how to do something, and I'll email it back. But yeah, don't forget the discussion question, and don't forget to actually submit your Google Docs work. And with that, I think we're going to end here. So have a good rest of your day and stay away from people. So long.